Yeah, good afternoon, everyone. I I hope you are able to hear me. Can anybody confirm?
Yes, sir, you are audible.
Yes, sir,
Audible.
you are audible.
Okay, okay. Thank you very much. Thank you. So, welcome to this second live interaction session. And today we will discuss about some of the issues related to the course that you have raised through the your account, and some of the queries that I want to address because when we are going through the question and answers, that queries that you are raising, we feel that some of the things we should make clear. Just a minute. Hello. बाद में अभी live session है. Just once. Okay, sorry. So, uh, yes, so there are few points that I would like to highlight because in the last first session also I highlighted this one, but some of the things I just wanted to repeat because many of you were not available in that particular meeting. So here, before you are asking your question, please read the forum discussion. So please keep following the question and answers that others are asking. So maybe some of the questions will be very similar what you are trying to ask, or you are trying to raise some issues that is already been answered to for some other student. Then please ask your question well before the due date of the assignment. This is very, very important because what happens if you are asking one day before the deadline, we may miss to answer that question before the assignment due date, and then you will be in problem. So try to raise your questions well before so that we will also get sufficient time to answer you. And some of the questions in your assignments are conceptuals. You need to use the concepts explained in the lectures to solve them. And here, as per the NPTEL guideline, you might have read the rules and regulation, and there it is clearly highlighted that some of the questions will be purely from the lectures and some will be purely from the suggested extra readings. So what I mean to say that you will have to see or refer different notes, different textbooks to solve the questions given in your assignments. Do not ask the same questions from your assignment. So what we face some of the problem, like some of you have just copied and pasted the same question in the query form. And there, if we are not supposed to give you the answer, you are supposed to find the answer of those questions which are given in the assignments. Lecture notes are not available by me, and I will not share any PDF, PPT. Everything is already been shared by the NPTEL team. So you just refer the website, there you will get notes, everything is uploaded. Only thing is PPT I am not sharing because you already have the video. You can refer anytime, any lecture you can refer. So before taking questions directly from you, I will just try to answer some of the questions which we have received through the Gmail, or maybe through this one link was circulated to you to raise your question for the live session. So here one question one student has asked, like I'm a graduate engineer from ECE and I'm interested to do post graduation in IIRS. I'm interested to work in DRDO, ISRO, or in Army lines. How will I get there? And are their placement good enough? As I don't have any idea, please brief me. See, these are like what questions you are raising. I can understand your mental state, but these questions I cannot answer. You will have to find out with the concerned institutes, concerned courses, and then you can, because you know what are the requirements to enter into ISRO or DRDO. There are sets of exam that you need to clear. You follow those syllabus, you prepare well, and then you appear for the exam. And from my side, only one thing I can say, that is all the best. Right. Then the second query was raised by, I think, two students. That was for the assignment 6, question number 16. Different valence state in same metal can be studied because of crystal field effect process and the charge transfer processes. So here in the answer, it is having only the D, which is crystal field if processes. So what you can, what I can do is I can ignore this question in your assessment, right? So I will make sure that it has been removed from your final calculation. Now, another question that was, can we use HRS imaging spectroscopy or spectroradiometer for water quality detection? For example, change in concentration of nitrate nitrogen level in river water due to untreated industrial effluent disposal. So basically, you want to go for the water quality using hyperspectral or imaging spectroscopy or spectroradiometer. So if you remember, I explained the spectroscopy term, that many instruments like ICP, XRD, XRF, we are doing the spectroscopy, but still that is different from hyperspectral remote sensing or remote sensing. But there also we are following the same principle. Only thing is, here I would say that using imaging spectroscopy or spectroradiometer, you can identify the concentration of any given element or material if the concentration is in ppb level. If something is in ppm, you can identify the concentration when it is in ppm level. If it is ppb, you will not be able to identify, because the impact of that particular element on your spectra will not be sufficient to be captured by your sensor. So here there are many research going on where people are using hyperspectral remote sensing or the spectroradiometer to identify the water quality. And there are well published papers. So it will be better you just refer those papers, right? Now the next question was asked for lecture 16 HRS1 spectroscopy. So will these videos will be available and accessible to the registered candidate after the exam as well? As of now, what I'm not very sure, but I guess that these videos are uploaded in the YouTube, so they will be available for any candidate, any person can access and watch them. And then the student has asked one question, what is happening in this video at 17:27? I don't know. Maybe this is because you need to highlight a particular time to ask a question. So it could be because of that. But let me try to explain what was covered at that particular time, 17:27. So I hope that now you are comfortable with panchromatic, multispectral, and hyperspectral concept. So when we say panchromatic image, they are single band images and they have been generated using a relatively wider wavelength range. So once you are keeping your wavelength little bit broader, then you will have enough energy and you can resolve the smallest unit of the ground. right? So that's how we are having very high spatial resolution images with panchromatic data. When it comes to multispectral, we have tens of band, but minimum more than two bands are multispectral. So here the spectral resolution is increasing, but when we increase the spectral resolution, you will have to compromise with the spatial resolution. So that energy and the wavelength relationship you have to remember. Then when it comes to hyperspectral, here what happens? The individual pixel is actually captured in different wavelength region. And here the bands are more in number, they are contiguous in nature, and their bandwidths are relatively very less. So 10 to 20 nanometer, and numbers of band will be in hundreds, and you will call them hyperspectral. So basically the main advantage you are getting with hyperspectral data is spectral resolution. And as I mentioned earlier in my lectures, that when a light interacts with the matter, what happens? There are fundamental processes that object will reflect, or this will absorb, or this will transmit. And if it is absorbing, it will re-emit those energies at the longer wavelength. So that is happening. So here when we are characterizing or when we are capturing these particular energies, you will be able to identify which material is sensitive at what particular wavelength range. So here we will get the characteristic wavelength range where a particular matter or object has a distinct characteristic absorption feature. And these features will be identified and studied to identify the concentration of that particular material. So here, spectroscopy is the study of a spectral feature which is dependent on the wavelength and the material object. I think this is clear to you. Spectroscopy is often used in physical and analytical chemistry for the identification of substances through the emitted or absorbed spectrum. So analytical chemistry means you can refer any of the conventional machines, that instruments which have been used to characterize a sample in terms of their minerals or their elements. So that is based on the spectroscopy, right? So how we are utilizing that particular information and that particular technique here in remote sensing. So considering this is your target, and here you have a source of energy. So in nature it is sun, in lab it is a characterized halogen lamp. So here we are illuminating this particular object, and then as per the basic physics, the light will be emitted, reflected, absorbed, transmitted. And if we are working in the wavelength of 0.4 to 2.5 micrometer, our detectors can measure the reflected energy only. So here, this is getting reflected and which is getting captured by our sensor, right? And this is getting converted to image. Now here, what happens? You have hundreds of band captured in different wavelength ranges, and each band has a very small bandwidth, and there are no gaps between the first and the second band, right? If that is the orientation, then you will have the continuous spectral behavior of a particular material. So this is the material, and here you will get this kind of images. And if you click on any of the pixel, you will get the spectral behavior of that particular material, which has been which have been present on that particular pixel on the ground. And then you can see this kind of spectral behavior. If so, you can analyze the characteristic absorption features and you can identify the material, as well as you can say that within the field of view, within the pixel, what are the different elements or the material or mineral or the rocks they are present, right? So that is the deconvolution of the spectral measurement. Now, spectroscopy can be grouped into different classes depending upon the measurement. So we can have absorption spectroscopy, reflectance or emission spectroscopy, and scattering spectroscopy. So here the imaging spectroscopy, as I said earlier, in spectroscopy, we measure the spectral behavior of any given material, right? Where light is used to illuminate the target, then the amount of the energy which is getting absorbed or which is getting transmitted or which is getting reflected, that will be measured and that will be used to characterize your sample. Now, when we say imaging spectroscopy, basically there it was only a point measurement. But here in the imaging spectroscopy, this is for the entire area. So you will have maybe, for example, 10,000 by 10,000 pixel to represent a particular area. So you have 10,000 by 10,000 spectra, which is stored in the form of images, which is available in hundreds or 200s band. I hope this is clear. So here what we do to acquire the spectroscopic information over large area, and it has power of both spectroscopy as well as imaging. So this is remote sensing part and this is spectroscopy part. So with hyperspectral remote sensing or imaging spectroscopy, both terms are same. You can characterize a sample and you can go for the uh, internal atomic structure identification or their mineralogical identification or elemental analysis, right? So here we are clicking on any of the given pixel and then you can get this kind of a spectra. Then go for the spectral uh, deconvolution. So here you can see the different types of material. They are having distinct absorption feature and their spectral behaviors are completely different. Different terms we are using spectroscopy, where we can consider all the instrument used in chemistry, physics, and where we are deriving the composition or the mineralogical composition or elemental composition. So that is spectroscopy. Imaging spectroscopy and hyperspectral remote sensing, both are same. So don't get confused, right? So that's all from my side. Let us see if you have any concern or. Yeah, any question if you want to ask? Yeah, so yeah, Anamika, good afternoon. So you wanted to calculate urban heat island, right? Using remote sensing. But see, if you have any specific question not related to the course, this is something you want to do using these concepts. So what you can do, you can write to me separately. I will provide you the answer, right? But this forum is mainly to answer if you have any questions related to my lectures, the content, the syllabus of this particular course. And I would suggest that you do some basic readings, because nowadays all the journal papers, they are freely available. All are becoming open access. So you have very good access to all the journals. Earlier it was not. But if you are in IITs and IITs, again, the library is good enough. But if you are from Central University or State University, nowadays all the papers are available in open public domain. So just Google them and download them, read them. because don't look for the shortcuts, right? Even when you mail me and if I answer to you, it will be a very short answer, right? It won't be covering the complete understanding. So once you read the basic papers, basic books, then only you will be able to perform the analysis. So please read books and the papers which are available. And even then, if you have any doubt, you are most welcome to contact me. So till I get the next question, uh, I hope you are enjoying my course. I hope everything was the concepts are. I tried my best to explain all the concepts. So because enjoying a particular topic or particular subject is most important. Yeah, many students might have joined just to get the credits, but still, this is my sincere request that you please understand the concept. Doesn't matter whether you are going to use it or not. Maybe in future, knowledge will never get wasted. It will be used some point of time. Yeah, Saeed, what in India is on the rise? Remote sensing, for someone who's not from a tech background. I am a student of geology. Why GIS is not considered to be a favorite career option? Yeah, this is, see, you are saying you are a student of geology. Even I am a geologist, right? Basically, I have done geology. And then I learned remote sensing. I did courses on remote sensing, and then I am using it. So don't get afraid of basic physics, chemistry, and maths. Whatever is used in remote sensing to understand the basic one, these are very, very basic, 10th, 11th, 12th class standard. So don't get afraid, right? How we can calculate radiance to reflectance, Aswarya. So it has already been explained, right? So you please refer to my videos. These are like, I, if I remember correctly, I gave some sample questions also to calculate. So you please don't skip the videos, right? And don't fast forward it. So you try to listen the complete content. Then Tarun, why the satellite data is divided into levels like level 1, 2, 3? What is the main reason? So Tarun, what is happening when we collect, if I assume that you understood the basic concept that how we generate the images and just, yeah, how we generate the images, and when we generate the image, so let me cover from the basic. Let us say this is your satellite and this is your surface. So sun is here, it is illuminating this particular surface, and the surface is reflecting some amount of energy, and which we are capturing at this particular level. So this is sensors which are sensitive to a particular wavelength range, and they are used to capture the energy which is getting reflected from the surface. Now, using the analog to digital converter, what we are doing, we are converting this photons, the reflected energy, into some numbers, and they are known as digital number. So depending upon the analog to digital converter characteristic, your data may be 8-bit, 10-bit, 12-bit, or 16-bit. Now, you have DN number that is level 0, right? someone just want to use the reflectance value, and someone is not very comfortable in converting dn to radians, radians to reflectance. So for them, maybe for a particular sensor, you refer their website, they clearly write level 0 is the raw data captured by the sensor. Level 1 is the calculated top of the atmosphere reflectance. Level 2 is reflectance geometrically corrected or terrain corrected. So all these informations are given in their website. So now very popular sensors, like if you take Landsat or Sentinel, you refer their website, these things are clearly mentioned in their website. So before you download, you just read which particular product you want, right? So that is the meaning of level 1, 2, 3, or depending upon different sensors, these numbers may be level 0, level 1, level 2. Okay, Aswarya. Any other question? If not, then we can close this session. And if you have any question, then I'll wait. Maybe I'll wait for next 5 minutes and then we will close this session. Yeah, one thing I just wanted to mention, that I received some of the questions in the last live session, before the last live session, that we do not have any hands-on labs for this particular course. See, this is very difficult to conduct under the umbrella of this particular NPTEL course, because this is pre-recorded and we are following your questions and we are trying to answer you. And then every time you will be visiting the examination center, and then but conducting the hands-on, it will be difficult because we need to be present, and that is difficult. So sometimes I do organize different conferences, different workshop, different training program. So if you are interested, keep looking, or keep an eye on my website, that IIT Guwahati website, where my web page. And if anything is there, you can join. So maybe sometimes it is online, sometimes it is offline. So I'll be happy to help you if you have anything. Yeah, we have one question. Can we have any equation derived like NDVI for water quality change detection? So one thing, if you water quality change detection is not possible. See, you will first, depending upon your element, you will have to design a particular method. And that method you can apply for different time temporal images, right? Then you will get the changes. But as such, as per my knowledge, it is not available. So for water quality, there are certain indices, but I'm not sure that whether that will help you or not. So if you have understood the concept of developing a particular band ratio, then you can do it for your particular element. And if you are getting some result and good result, which is sensible and matching with the result, then use the same method for the next image or maybe the previous image. Then you can identify the changes. But personally, I will suggest that if you are working with water quality, and because these are not permanent thing, right? They are changing with time. So lean season, it will be different. During the peak season, it will be different. So try to develop your own method, read some papers, and then on that basis and the understanding of that particular element, because everything will be based on your information, that what are the elements you are looking for in your water. Randomly, you cannot go for it. So perform the conventional analysis, identify a particular element which is more in your water, and then you can go for the contamination mapping or something like that. I hope you understood the concept. In which of the following cases would remote sensing be relatively most useful? Urban mapping, coastal monitoring, volcanic eruption, forest canopy. Uh, how we have to approach these questions, sir? Okay, so all these areas, see, urban mapping, I would say, like all these areas are the hot topics, right? So my research scholars, like my PhD students, one of them, they are working, she is working on urban mapping, urban and atmosphere interaction. Then atmosphere and coastal interaction, that is the research topic of my another student. Volcanic eruption, as such, I am not working. Then forest canopy mapping, these are well established method. Like you can identify even the species of the forest, like what are the species available in a given area, that even you can identify using hyperspectral remote sensing. So again, how to approach? Read the basic questions, and then it read some latest papers, old papers, and then try to frame a methodology where you can use remote sensing, not necessarily, and then you can go for the analysis. Uh, is it long question also will come in main exam? See, the questions will be similar as your assignments of same nature. But the distribution you can understand or refer the NPTEL website. There they have clearly written that what will be the syllabus of your end semester exam. What percentage will be from the lecture PPT, what content or how much content will be from the reference, how much content will be from the conceptual understanding. So everything has, and even the numbers like how many questions will be in objective, how many for the numericals. So everything will be clear after reading those guidelines. So I hope, Akansha, that is fine. So if you do not have any further question, we can close this. So personally, thank you very much for attending my course. And I'm hoping that you are enjoying my course. And if you have any query, again, there is a proper way to ask your questions. And even after this course or this course is over, even if you have any specific question, you can always write to me. Right? So thank you very much. So I think no other questions. So we can close this session. Thank you very much. Thank you.